the earth, uh, keep them for future generations. So, does anybody have like? So she accuses people in here of having a fear of time. Does anybody feel?
Chronophobia.
Yeah, chronophobia. Does anybody feel daunted by the fact that the Earth is 4.6 billion years old and humans have only been stalking around for
Yeah.
like 10,000 or so?
I felt that way. Yeah.
Yeah. Yeah.
Not the past part. I mean, that kind of happened already. Like, what am I going to do about it? If it's 4 billion years, even if it was 2,000 years, what am I going to do about it? It's the future. Because there's so much before me, that means there's so much after me. That's the daunting part for me, psychologically.
That's a good way to think of it.
I need a psychologist here.
For me, I look at the first like 2 billion years of Earth, and it was black and it was hot and it was uninhabitable and uninteresting. So it's like, okay, 2 billion years went by before the party even started. When did the party really start? About 9/10 the way into Earth's life. The party only started 541 million years ago. We can get with that program.
So does that, when we're talking about like how we date and age, I asked this question to our last guest. I asked, are calling insects bugs demeaning? He said yes. You should refer to them as insects. When you're looking at a rock, is calling it just a rock feel like a little devaluing of what you can learn from it?
No,
just calling it a sample, a rock.
No, geologists when they're just hanging out comfortable, they call things rocks.
They just call it a rock.
There's minerals, and those are particular chemical signatures, and a couple of them together makes a rock.
Okay.
So, but you will also hear geologists call things facies. Like we needed a pretentious word for rocks, right?
So we have
Didn't
one.
we all need a pretentious word for rocks? So if you want to sound pretentious and geologic, you can say that rock facies.
Oh,
which is just
I kind of like it.
A kind of rock. Happens to be in the dirt you're looking at.
So you talked about like what makes Earth unique. Does that make the study and the geology of Earth versus non-Earth rocks, like space, does that make it different in a unique field in and of itself?
The Earth is pretty unique. I won't say it's unique in the universe or anything, or even in the galaxy, but it's really unique in our solar system. We have a magnetic field. Yeah. No other planet still has that. The other planets, and so I'm getting some guff from my husband. You wanna raise your hand? Tell me what. Jupiter has a magnetic field. All right, so let's all go live on Jupiter. I don't think so. So the magnetic field on Earth preserves our atmosphere from being stripped away. It gives us these beautiful auroras. And Jupiter probably has an iron core causing its magnetic field the same way ours does, but our moon long ago lost its magnetic core. It solidified, a liquid magnetic core that is long ago solidified, same with Mars and that sort of thing. But it's a pretty neat thing to have, an atmosphere and a magnetic field that preserves the atmosphere and those beautiful auroras that we get. What else is unique about the Earth? One of the things that cooled me out about our magnetic field is that every 200,000 to 400,000 years, it flips. The North Pole becomes the South, and the South becomes the North, which is not to say that the Earth, as it goes around, flips on its head. Just the magnetic field flips. So everything that we have that depends on that magnetic field for navigation, like birds and whatnot, and all of our electronic stuff, that would really be a mess. Fortunately, it takes like 10,000 years for the magnetic field to flip. It happens only every 200 to 400,000 years ago. And 42,000 years ago, we had a mini flip, which might prevent us from having the next big flip anytime soon. So
that's reassuring.
Yes.
We'll call it our favorite magnetic field.
Yes.
Maybe not the only, but our favorite one in the solar system.
Yes, we like north where the North Pole is.
Yeah, and Santa does too.
Right.
So South magnetic pole and the North geographic pole.
Yes, you do, but that's what makes the compass point north.
Yeah. Yeah. Yeah.
Oh no, we got
Whatever.
we got the physicists, we got the
Yeah,
astronomer.
Yeah. We're not going to worry about it. Magnetic north is near the North Pole. So there.
So you talked about earlier about subduction, and is that I wanted to ask about movement of the continent. We think of continents in our geography as very static, but that is not true. They're constantly. Is it a constant movement only during events like earthquakes? Do we feel it? Can we see it? Is that something that's happening now?
We actually can see it now that we have GPS. We can see that parts of our continent, the North American craton, the central part of our North American continent, is actually moving. And we have a record of data from, I think it's Denver, Colorado, that tracks how our continent is moving. At the same time, you'll notice that we have volcanoes in the northwest, like Mount Hood and Mount Rainier and that sort of thing. Those are from the subducting ocean plate that's going under the North American continent.
Okay.
In fact, the reason we have the Rockies and other high plateaus out west is because there's already a continent buried under our continent. It's called the Juan de Fuca plate. It's stuck under us and lifting our western part up. So does the Juan de Fuca make my western part look fat?
Oh my God.
And so we can see the movement of the plates. And that, to me, that's very reassuring. That's a piece of geology that we can see occurring in our lifetimes. It moves like 13 centimeters a year. And 13 centimeters isn't a lot, but it's enough to see the movement.
I mean, on a planetary scale over time,
yeah.
I mean, so how do events like earthquakes fit into what the book talks about, uniformitarianism? And like that's because like large movement events like that don't feel uniform, but is it just because it's a natural part of how
uniformitarianism is an interesting concept. It doesn't say that geology is smoothly moving through time. What it says is that what we see going on now, whether it's strike slips and earthquakes and that sort of thing, or subduction of ocean plate under continents, what we see going on now is the same thing that went on in the past. So we can use what we see now to make guesses and theories about how things were formed in the past, and we can rely somewhat on that these things will continue throughout the earth in the future. So if we see the United States moving slightly to the southwest at 13 centimeters a year, probably next year we'll be moving slightly to the southwest at somewhere around 13 centimeters a year. You get the idea.
Okay.
But earthquakes, which happen very locally, the earth does strike slip. It gets stuck to two pieces against each other, and they want to move. They're being forced to move, but they're stuck, and all of a sudden they unstick and they move quickly, and that's an earthquake for us. To the earth, it's probably, excuse me, but for us, it's devastating, depending on where and when it happens. Two big ones recently in Venezuela and Colombia.
Yeah. And that brings us, I think, into our first turn in talk. So I want to ask, the author talks about the Anthropocene and whether there should be a geologic definition of the impact that humans have on the earth, and if that needs to be considered in this geologic timescale. If we're it's because we're having an impact on the earth. We know this, but do we need to define that geologically? I think it's an interesting question. So so we can talk about it for the live stream, and then we'll come back. Give it basically everyone at your table. You get like 5 minutes. You can talk about it. The idea of
let me define the Anthropocene.
Oh
here.
yeah,
there's some argument among geologists whether we should start a new time marking. You know how we had things like the Triassic and the Jurassic and the Cretaceous and the words you've heard before. Should we say at the start of the atomic bomb or at the start of the Industrial Revolution? Should we say that this is a new time? We'll break it off right now and start a new time period that's called the Anthropocene because humans have influenced it so much. And there's great debate among geologists whether we should really start a new time frame called the Anthropocene. So what do you all think?
Yeah. Well, it settled many a debate before. Like we basically set the rules. So like no pressure. Yeah.
Have I'm not hard and fast on this. I do feel that, especially with the calculations I just made today about global climate change and earned a demerit. Yes. Yep. Yes, there are a couple of points, either right when the Industrial Revolution started in the 1800s, or with the first atomic bomb in
In the
the
1940s
1940s,
or 40s. Yeah. Sorry.
testing and stuff. Yeah.
Yeah.
So we actually have irradiation markers in all our soil now from that first atomic testing. So there is a layer that indicates, hey, this is when there were atomic bombs going off.
So we have already, there's
We have a
very
layer in the
clear
soil.
delineation of
Yeah,
here
yeah.
is
We also have layers in the soil of industrial pollutants and whatnot. The
even
same
from
way.
the 1800. Oh my god.
Yeah, well, we had so much coal burning,
even
you could hardly
early
breathe
19
in London in the
yeah.
1800s at some point. So
And so that shows itself already.
those are in layers, yeah, that we can see. They're very close to the
Oh.
surface, but there they are.
Oh my god.
I know.
Oh, so because I was
Yeah.
going to ask, is there really geologic evidence?
Yeah,
Would you say? But it sounds like there is.
yeah. There's some geologic evidence that we
my
have
God.
contributed to a new era with certain things in the soil.
Yeah. Well, I
Yeah.
think the author proposed like 1950 cutoff, but that felt weird. Felt like a
Yeah,
weird
I mean, that
number.
would be slightly past
Later.
the end of the atomic testing.
Yeah.
After that, there was a moratorium on atomic testing. So there hasn't been as much since then, but up to then, there was pretty serious testing. And yeah.
I didn't realize that was evident, like in
Yeah.
the. Oh my
yeah.
god.
No, the radioactive fallout comes down in rain, it lands in the soil, as more soil goes over it, and over time, there it is, a layer. So,
Oh my
yeah,
gosh.
it's weird.
That's crazy. I mean, that'll be used to date. I'm assuming that'll like radio.
Used to date soil. It's like,
Yeah.
oh, this is from the 1950s. Whatever.
And they'll say, well, it's also
Right.
full of lead.
Here's the coal layer from it's the same as the coal layer in London from the 19 or 18 whatever it was. So, yeah.
Well, and I thought it was interesting too. I had never heard of a lot of those dating methods talked about.
Yeah,
early.
that's
I had only
another
heard
thing
of
I love
radiocarbon
about
dating, and she
geology.
was like, "That's terrible."
Well, no, radiocarbon dating is great for things that are less than 12,000 years old. So most bones and teeth and stuff like that of humans.
Yeah.
But there are some that go. My favorite is the old one. The uranium decays to lead. That's a long decay. It goes through thorium, so you can do uranium to lead or thorium to lead,
Yeah.
and that'll tell you things like the age of the meteorite, which was probably formed when the solar system formed, and that's why
Okay.
meteorites might be interesting and useful because the Earth formed at the same time as the rest of the solar system. We're not
Yeah.
special or anything. So when the sun formed and there was all that debris in orbit around it and it coalesced into planets,
Yeah.
that's the meteorites will tell us when was that. So
Yeah. Well, and I want to talk about, and we'll probably get into this with the PTM stuff, but just like the relationship between the geology, like the rock and the atmosphere, is so interesting. Because you wouldn't think, like, what does the air have to do with it? But
Yeah.
it really has a lot to do
yeah,
with it.
yeah, we can tell a lot about what the atmosphere was like at different times in on Earth from what's in the soil. So, as I mentioned in one point in my notes, oxygen really, really, really loves iron, magnesium, and silicon. So there's a lot of information on how much CO2 was around, how much oxygen was around.
Yeah.
at different times. So
Well, now you mentioned earlier that there was like a 2 billion year period. Earth wasn't doing much. How does that fit into the uniformitarianism idea when there was a pretty significant period we had nothing
yeah.
and then really kicked off?
Well, if you think about the formation of the solar system, okay, boom, there's a sun all of a sudden because enough stuff came together and it started burning, and it started burning its helium and hydrogen and out, making all these beautiful particles and makes a beautiful sun. Our early sun was really small, weak, hardly producing anything that would make the earth warm or anything. So that's
Sad.
called there's a early young sun paradox. How did the earth end up warm enough even though we had a pathetic little sun?
Yeah.
And why did we have a pathetic little sun? Because it's still gathering in, due to gravity, still gathering in more mass.
It's growing. It's
enough.
boy.
Yeah, it's like trying to get a fire started, right? You need enough
Yeah.
mass and enough heat, and then it finally gets going. All the planets were like that too. We had all of this detritus from this explosion that formed the sun, circling around the sun. Some of it's going to go into the sun and make it bigger and brighter. Some of it's going to stay in its own channels and coalesce together and form itself as planets. And so our planet essentially scraped out its path around the sun, as did each of the other planets, acquiring all the mass it could swoop through. And, some of it was as heavy as iron, and some of it was as light as helium, and some of it got crushed over time into things like uranium and thorium and different things like that. But the meteorites that now land on Earth, they formed at the same time. So they're like a clean version of the formation of the solar system. That Earth has been through so many cycles and had so much life on it, the cyanobacteria and everything. So we're not a clean record anymore anywhere. There's a couple of zircons from the Jack Hills of Australia that are early and somewhat pure also, because we can date them back to
So cool.
a couple billion years. But
Casual.
yeah, same with the green schist in Iceland. You have some pyrite that's like that. Yeah, so there's some dating that can be done with things on Earth, but really the meteorite dating was the first indication of a really true good number for the age of the solar system, which is essentially the age of the Earth. Now, when we date the Earth, it's just like a baby. Those first 2 billion years. I'm black.
They're not doing much.
I have no oxygen. I have no water. I'm black.
Yeah,
I don't. What am I doing?
Fun.
Right.
No
I'm
palm
not fun.
trees.
I'm boring. So we had
So maybe it's like a development.
Yeah. So we had the
it's changing.
Hadean era where it was like boiling hot and molten lava, and we had the now we're a black brick of ex lava, and so 2 billion years of nothing, and then finally the party gets started. So
and then the fun stuff happens. Really care about take off.
So Earth, they like to talk about the ages of the Earth in colors. So there was a snowball Earth, white Earth, and a black Earth, and a blue Earth when we finally got oceans, and a green Earth when we got cyanobacteria and oxygen. And so the ages of the Earth are often listed in what color was it at that time. Yeah. There's only been 4 eons of the Earth. So the Hadean and Archean were the 2 earliest ones, and the Archean was long and boring. And then the Phanerozoic and the Proterozoic eras were much more interesting with, okay, now we got bacteria. Okay, now we got mammals and things, dinosaurs, mammals, all that good stuff.
Is it that humans have, is it a human only effect, or do we also need to consider like a life on Earth as a separate?
So life on Earth did have its big marker. That was the great oxidation event, and that's an eon marker when we move from the Archean boring to the Phanerozoic cyanobacteria. So it got its own marker. We get our own marker, I guess. So
that's okay. That makes sense to me.
We want to get some answers from our crew
and
here.
see if somebody earns a trilobite.
What's that?
See if someone earns a trilobite, maybe.
Well, maybe if you want to give out a trilobite.
Yeah. We're good to come back if that's okay. That's okay. It's real casual. All good. Yeah, you had so many notes. I was like overwhelmed. I was like, oh my gosh, I don't know if we're going to be able to talk about all of this. But I want to hit the highlights with you. I want to hit your highlights. How about
Okay.
that? 'Cause I mean, this is you. This is all you.
Okay. But we were going to start with what people think about the Anthropocene. Not anthropic. The
And not,
Anthropocene.
not anthropic. That's a different conversation.
Yeah.
So, as we all know, this book club makes very important decisions for the scientific leaders of the world. And I don't know how we get these decisions to the right people, but I think we've come to a lot of good conclusions. So, I will do a soft poll and then we can get deeper into it. How many, raise your hand if you believe that we do deserve in our own geologic time marker. We deserve to be recorded. Okay, couple hand. Okay. Humans deserve, we earned it, guys. We have destroyed the planet. We deserve our own time. Does anybody think the humans don't deserve a geologic marker, a little marker in time? No Anthropocene. We don't deserve, we didn't earn it. We haven't polluted enough. Yeah, we called it a demark, like a
Demerit.
a demerit. Yeah, it's not really like a positive. Like, you guys really did great. You deserve. So it seems like generally we're on board. Like, humans have had such an impact on the earth. We deserve our own time. We deserve our own time, and we deserve to record it as such. Does anyone?
That's a good question. I don't
that's a
think
great
we're ready
question.
to go for an eon yet. That's mighty big.
Okay,
Let's say we're past the Holocene.
so we haven't earned the eon yet. Maybe we could. Yeah.
One thing about it is how you, so there's different definitions about what causes each one of these errors.
That's very true. Very true.
Biological and some geological.
Yeah, yeah.
Okay.
Geology is interesting that way in that they have it's a lot like biology. You know, they classified animals by what they looked like and what they did. So a marine iguana was a fish, right? No. So now they're using genetics to determine what things should be in the same families. Geology is kind of similar. It's like, oh, well, we looked at this, and this seems similar, and so we're lumping this together for this reason, and then these other things together for that reason. So it's really not well sorted yet. But yeah, you had a question.
I would just say it's also an argument within anthropology and
Oh.
and we're very divided, but we're also in the it remains to be seen if we're actually going to categorize this as the Anthropocene. Because
Yep.
are we going to have such a lasting impact that after if we survive as a species, that we'll be able to find fossil
Yeah.
records and things like to show our impact,
Right.
or is it just going to be like a blip?
Yeah. So
That's-
geologists, believe it or
that's-
not, are in the same debate. Nobody in geology is like, yes, we all agree this is the Anthropocene. But we have a couple of markers that Alice and I were talking about. One of them is that there is a rock record of nuclear detonations from the 1950s. And there's also a record of coal, sulfur, and coal ash from the 1800s, the era of industrialization. So there's a couple of rock markers already, but is that enough to qualify it as its own period of time? So,
Yeah, that's a really good point, though, that there are other fields that like deal on those time scales. And I mean, you're saying that like they're not resolved on this either. So it's an ongoing. What would it take? What would it take then to be scientifically defined as the human eon? Hey, we'll get back to you in about 500,000 years. We'll circle back to this, guys.
Anthropologically speaking, we can ask the our robot overlords in a few years. Right?
Someone put it into Claude now. Remind him.
I'm assuming that geologists are uncomfortable about naming the Anthropocene because it seems too egocentric.
Egocentric. That's a great, yeah.
The center of the universe, and now suddenly we're making man the center of the geology universe. I think that
Mm. Presumptuous and egocentric, and scientists don't want to be that unless they're naming something after themselves. It's okay. Yeah, Rufus.
I was just gonna say, it makes sense to name it if we exist or not, because if we don't exist, no one's gonna know that we named it, and if we do name it, then it's the name that we survive. Because
Well, that's a good point.
to my knowledge, dolphins aren't naming geological periods, so
But what if dolphins are naming geological periods? But you're right. If we don't make it,
then we need to peer review their work.
okay, we're peer reviewing the dolphins. Guys, important work is happening here. We're peer reviewing if the dolphins have geologic time. But that's a good point. If we're not here to name it, who would ever know that it's the Anthropocene? Unless there will be a fossil record of us.
This might be a
Right?
good time to award a trilobite.
Oh, would you like to award your first trilobite? A 3D printed trilobite, which moves and is very cool, by the way. Very cool, by the way.
Thank you, Elijah, for these gifts. I have more than I need, so I will give out some trilobites.
They are so cool. They move and they're great. I know.
All right, let me talk for a minute about index fossils. Trilobites are interesting because they're found the world over. They evolved fast, and so they have different markings for different times. So when a geologist finds a trilobite, they know that that layer is the same layer as layers found with the same fossil in other parts of the earth. So cool. All right, do you have a candidate?
Who do you want to give it to?
I mean, I like the obvious, if we're here, we're here. And we
Yeah.
don't need to worry about naming it. If we're not here, nobody's going to know that we named it anyway. So,
That is kind of yay. Your first trilobite. Our first trilobite. I know, and it moves. 3D printer files are going to have to be shared. I'm just warning you, Elijah, because that is very cool. What next? So I want to talk about, and if you guys at your tables, I probably should have opened with this. At your tables, I put 2 pieces of paper. One has a handout that Lori so generously and kindly made that I printed out. That was because things like Milankovitch cycles, guys, trying to read that written out and in my head, like organizing all of the pieces and like orienting in 3D. I'm not a 3D printer. I cannot think like I did very well in histology. I still cannot think like that on a planetary scale. Pictures are very helpful. 2, I also put a QR code. I promise I made it. It's not a sketchy QR code. It's a legit QR code to a video that Lori recommended. And we don't have AV here, obviously, to watch it together, but you guys can put it on your phone, watch it on your own time. But it's a very good summary, I will say, of like the process of the Earth.
3-minute history of Earth. One of the handouts, I think the one that has the video link on it, also has how geologists talk about the times of the Earth by color. So there was a snowball Earth and a black Earth, and the Hadean hot Earth that was red, and different things like that. So it's hard to believe that we spent our first 2 billion years first flaming hot lava and then black and boring. But then things started happening.
It started to get fun.
Atmosphere, cyanobacteria.
So I want to talk about PTEM. What does that stand for? What is it? Why is it important?
It's the Paleocene-Eocene thermal maximum. One of my favorite concepts or happenings in geologic time. It's the border between the Paleocene and the Eocene about 55 million years ago. Why is it interesting? Because the Earth had a spike of very hot temperatures. It was 5 to 8 degrees Celsius above today's heat levels, and there were no ice at all. No ice,
No
glaciers, nothing. No ice caps, nothing on the Earth. There were palm trees at the poles. And as you might imagine, this would have been a struggle if it occurred slowly, but it occurred in fairly fast geologic time. So let me see if I got my numbers here. I did the math on this. The length of the spike is thought to be about the first 5,000 to 20,000 years of the length of the Paleocene Eocene thermal maximum, which was total 150 to 250 million, or 150 to 250,000 years total length of time. So short time geologically. If we're talking
Yeah.
hundreds of thousands, it's short.
Yeah.
Um,
Just a few 100,000.
but the release was between 2,000 and 6,000 megatons of CO2. That's what they think. If we look at what we're doing today, we're currently emitting 38 gigatons per year. 38 compared to 2,000 or 6,000, not much. But over the time period, we're doing 38 every year. That's 150 years maximum till we hit that amount that was released during the whole time of the Paleocene Eocene thermal maxima. 150 years, and they took up to 5,000 years. So we are really pumping out the CO2 at the moment, seriously. This is a seriously not good thing unless, you really do plan to move to those Florida condos in the Arctic, Antarctic, whatever. Can't go to the Arctic. There's only land in the Antarctic, so better head south.
So what does studying that period geologically tell us?
So you can see what happened to the critters back then.
Oh.
At that time, there were interesting mammals running around. No more dinosaurs. Dinosaurs were gone. And the mammals that were around were like deer and early horses and things like that, and smaller critters.
Mm-hmm.
But they went on huge migrations to try and stay someplace where it wasn't too hot. The worst thing that happened in the ocean was acidification, and some 90% of shellfish died off. It's their calcium
90%.
shells just dissolved.
Yeah.
Yeah. So no more oysters. If you like oysters here, better watch out.
Yeah.
So yeah, chapter 5 is pretty dire. Chapter 5 is like, oh my God, we're all gonna die. Only she does it very nice and scientifically. She never says, oh my God, my hair's on fire, we're all going to die. So she's very scientific in the book. And so, she's done all this geology for you in chapters 1 through 4. Chapter 5 hits you with climate change and what happened during the Paleocene Eocene thermal maximum.
Mm-hmm.
And then she also takes a stab at some of the people nowadays who are trying to engineer solutions to this with carbon sequestration or seeding the atmosphere and different things like that to try and engineer our way out of it. Instead of reducing production of CO2 and the other gases, greenhouse gases, let's just try other things to engineer our way out of it. She's very cynical about that.
Yeah.
And then chapter 6 is her ray of hope, where she talks about what solutions she proposes, what we should be doing next.
I want to go back to the engineered solutions. I'd love to hear everyone's thoughts here, and we can make it a turn and talk, or you can just, if anyone has strong feelings and opinions. She talks about carbon sequestration, but she also talks about that, seeding the air to try to mitigate the effects of global warming. That I had never heard about that, actually. This was my first introduction to that method.
So the precursor to this is the eruption of Mount Tambora in 1816 caused the year with no summer, because it released so much particulate into the air. It sort of acted like an umbrella shielding the sun. So we never got as warm in that year as we normally would have because of that eruption. And people are talking about throwing the equivalent of a Mount Tambora of sulfate aerosol into the air. Now, the problem with that, obviously, is that you can't have a Mount Tambora happening all the time every year to just shield the Earth from the sun's rays. Other things need the sun's rays. We need them in correct amount. And how many of you would give up this beautiful blue sky we had today for a continuously white sky? Not going to rain, but it's never going to be blue again because of the sulfate aerosol. You can't just engineer a solution and have everybody on Earth say, oh yeah, that's fine with me. No more blue skies. It's okay.
I'm curious if anyone else's thoughts on those engineered solutions. Again, I had never heard of that before, so this was new for me.
So, my concern is the following. My following in the literature for the last 10, 20, 30 years is that climate scientists are opposed on principle to looking at engineering solutions.
Okay.
And I would say we need to look at them, and if they're crazy, put them aside. But maybe there's one we haven't thought of yet that's very clever. So
Okay.
I object to being opposed on fundamental principles to even considering these options.
Okay. So it's worth at least considering an engineered solution.
Here's one I like. You might
Okay.
like. I don't know. In Iceland, they have a test facility that basically shoots soda water, soda like you're drinking here tonight, into the earth. Now, Iceland is what we call very mafic. It's got a lot of iron and magnesium, and iron and magnesium really, really love oxygen very, very much. And they will take that carbon dioxide that we shoot down into the earth and bond with it and keep that carbon dioxide down in the earth, becoming a slightly different form of mafic Icelandic rock. Can we do that at scale? Can we do that other places than Iceland? There's a lot of questions here, but that is one of the carbon sequestration solutions where we don't block the sun's light and we try and absorb CO2. There's other engineered solutions that are like fake trees that
The fake tree. I forgot about that.
love
trees.
carbon dioxide, and they'll give off oxygen. So instead of, why don't we make more trees? Why don't we make fake trees? So I don't
That's fair.
understand that, but
Sneak back behind the pole.
Concerned about unintended consequences.
Unintended
Exactly.
consequences. That,
What it will cause on the other side.
exactly.
yeah, that's yeah. Okay, temperature goes down. We don't have sun. Plants. Too bad. So sad. Seems like a
They're the ones who
big-
eat the CO2 and give us oxygen. So
Yeah. No. There were thanks for bringing up the fake tree. Thanks for talking about fake trees because there were a lot of things proposed.
So a lot of those climate engineering things have to do with controlling the atmosphere somehow.
Controlling the atmosphere, yeah.
Suggestions about how to control the acidification of the ocean.
yeah,
That's
I
a
don't,
good question. Controlling is ocean acidification. Stop focusing on the atmosphere. That's a really great point.
Any of my geology friends here know if there's anybody doing anything on ocean
Ocean
acidification?
acidification.
I'm not aware of anything that's like adding Alka-Seltzer to the ocean or anything. Might be out of there. I don't know. Tums for everyone.
Yeah, Tums for our oceans. I mean, that sounds crazy, but that really feels. Well, I mean, she talks. I guess she talks about it in the book about how the erosion of the Himalayas specifically contributed to like the atmosphere. So is there a geologic solution? Do we just like start chipping away at the Himalayas and it brings the temperature down?
Yeah. Yeah.
Maybe that's what we need to do.
Always reminds me that Indiana is actually eroded Appalachians. The Appalachian Mountains used to be as tall as the Himalayas, but here we
What?
are instead. It's Indiana now.
Also, where I'm from, we call Appalachia.
Appalachia. Appalachia used to be as tall as the Himalayas or Himalayas. I don't know.
Oh, hold on. Himalayas, Appalachias.
I don't know.
Did anyone else have any thoughts about the engineered solutions? I like the idea of we should just keep exploring it and look away from the atmosphere. Take notes. Anyone, whatever engineer is listening to this, take notes. We have ideas. Any funders?
Yeah, but then you get these morons with these ideas about putting reflectors, reflector mirrors up in space.
Yeah. Yeah.
Put what? Reflective mirrors in space to reflect.
You can order
Reflect, yeah,
it. Get online and you order it.
it's already been approved.
Say, I want this.
It's already on Amazon. What
That's
are we
weird.
doing?
Satellite prototype
Hmm.
try to do this.
What?
And the idea is that you could, if you like search and rescue mission or something in a dark place, you could put light on it. Construction lights instead of having all those bright lights around construction.
Yeah, I-
Having channel light. That's the engineering
I'm not sure we want to do that to our glaciers because that's going to be a positive feedback loop there. Shine the light on the glacier,
Shine the
melt
light.
more glacier, it's more black, it's more less albedo. Yeah, gets hotter and hotter.
I would
So-
direct whoever is designing that. I would direct them to our crossings book where we talked about light pollution and how harmful it is.
to the
for-
birds.
Yeah.
Bird
Well,
migration.
and birds, animals, so many things. The light pollution is just terrible. But it brings us back to the unintended consequences. I mean, we can think of a solution. Okay, we're fixing this problem. We have created 17 more problems. That feels like a bad trade-off. If we're doing a cost-benefit analysis here, not really weighing out.
Yeah.
And the author talks about this too, even in chapter 5 and even into 6, about the motivations and how, this whole book is talked about through a scientific lens, but then really the motivations, even for trying to fix, call it whatever, fixing the atmosphere, fixing ocean acidification. Those motivations aren't scientific. Those motivations are capitalistic. And that
Economic,
fundamentally changes the solutions that are coming, that we're being presented with.
Yeah.
And we get solutions that harm plants, that harm animals, that ultimately have a lot of
Is it a world worth
consequences.
living on if we have destroyed most of the other large species and most of our sea life and that sort of thing? Is it worth?
Well, so let's get into, I'll call it our last turn and talk before show and tell, because Lori brought samples, guys. We're doing, I saved it for now because I was so excited when she told me. But our last turn and talk, at the end of the book, she gives some prescriptions. One of them being in geology in schools as like a foundational science. So you take physics, you
Geology,
take biology, you take
yeah.
chemistry.
Geology is taught in schools more as an elective. Everybody that wants to, go to engineering or go to college or whatever is going to take physics and chemistry at some level. But geology really isn't required. Astronomy isn't required. Those things I think people tend to shy away from because of this chronophobia. It's like, oh, those are too big, too long, too scary. So we don't require that our students really be as knowledgeable in geology as they are in physics and biology and chemistry.
And then the other prescription is this idea of a department of the future. And she introduces like the 7 generations ideology and not ideology, I guess kind of a methodology, yeah, of planning and thinking about the world. I'm kind of curious how you all received those 2 prescriptions. If you feel, and maybe you can talk about one, you can talk about the other. If you liked one more than the other, if you would be more willing to adopt one over the other, but Department of the Future and geology in school. And if you're in education and you're a teacher, close your ears because we're not trying to add to your workload. But I'll give everyone like 5 minutes, and then we can come back and we can go to show and tell, which is what I'm excited about.
The idea of the Department of the Future. At one point, the Defense Department wasn't the Department of War. And
that's true.
for a good 20, 30 years, at least since I was in college, the Department of Defense really had the mandate to think about the future. It's like,
Yeah. Oh, yeah. Sorry.
so climate-induced migrations and starvation and diseases, that was their job to focus on that.
Yeah.
I know my friend who was director of high-speed computing for the Department of Energy was drawn into Washington to oversee COVID response.
Oh, wow.
They turned the Department of Energy supercomputers on modeling the COVID pandemic. So
Jeez.
there are departments already that have a side task of thinking about the future. And I
But it's a
I think
side
right.
task.
And I think it would be fabulous if we had a Department of the Future that could draw on the resources of our other departments that could have that time and space to think about it. I had a friend who worked in deep space propulsion at NASA. We
Ooh.
are not sending anybody to Alpha Centauri anytime soon, but there was somebody whose job it was to think about, hey, if somebody's out there, what kind of propulsion systems would they use to get here? How would we get out into the
Oh,
world?
interesting.
So it was a great position for being able to have that space and freedom to think about questions of importance, but not
Mhm.
immediate importance.
Yeah.
So I think a Department of the Future would really carve that space out as my favorite solution in the book. I mean, obviously, I'd love to see geology taught more. I never had it. I had physics and chemistry, but I
Yeah.
never had geology in high school. I think it
Yeah.
would be good to get students thinking about geologic time.
Yeah, I actually took an advanced earth science course, but it focused on like plant and like the biological science.
Sort of more of an evolutionary side. Yeah, you
Yeah,
can't have
and, like,
evolution of
environmental.
things without their environment, right? So
Yeah.
it would be a really nice thing to do together.
Yeah.
Evolution of Life and Earth, the course that I took at IU.
Yeah.
So,
Yeah, something like that on a
I also took paleoclimatology, another fabulous course.
Ooh.
What was the climate of the Earth like over all of its time periods, including these little blips like the Paleocene Eocene thermal maximum?
Yeah. Well, I mean, those little blips though tell us so much about what happened, and I mean, it
They're
almost feels
great.
like a sign of things to come.
Gedanken experiment or model for maybe what we can expect from CO2 levels of certain amount. And
Then why
you know,
why do we not, when we're talking about climate change, when we talk about conservation, why are geologists not? I mean, they're not the only. I would say one of the few hard sciences, what we call hard sciences, which is a terrible nomenclature, but that really are able to think, like normally actively think on these timescales. I mean,
so one of the things that I've noticed at IU Indy is that they've split out into a degree of environmental science and a degree of hard rock geology, essentially.
Yeah.
And they don't meld the two.
oh,
You can take courses across. A lot of students do,
yeah,
but the thinking really is a little bit separated like that. And
Yeah.
maybe it shouldn't be.
yeah, it
But
feels like it
when
shouldn't
students
be.
come out and they want a job and they want to help the environment and they want to come out with an environmental science degree, I'm not going to stop them. That's fine.
No.
That's good. And it's good that they have to take some other geology courses also, but the full
Yeah.
range of geology courses they're not going to have time for
No.
because of a lot of focus on environmental chemistry and all other things.
Yeah.
So
Just generally, I feel like when we talk about like environment, conservation, and climate change, like we hear from the conservationists, the biologists, the botanists, urban ecology,
possible
forestry.
that-
We don't hear from
it's
geologists.
possible that geologists are too used to thinking in deep time. And it's like, oh, it's only a couple thousand years or tens of thousands
Yeah.
of years. And then
No big
we'll
deal.
be on the other side of it.
We'll be on the other side soon.
No, we
But
as
she
humans
presents a
won't,
great
even our
argument, though.
children's children won't.
Yeah.
But maybe they do think too geologically, I
Yeah.
know since taking all these geology courses, I know I'm more sanguine about things I can't control. And,
Really?
yeah. And I look at rocks and I think it's so cool that was there so long before
Millions
you know,
of years.
and the continent that we're on. I mean, not only did we used to have a supercontinent, but over time we've had like 9 or 10 supercontinents. They've come together and they've gone apart again, like
Yeah.
duckies in a bathtub.
Yeah.
All the duckies are in one spot. Now the duckies are all spread out across your bathwater. This is what the continents look like they're doing. It's no
Yeah.
wonder that early geologists thought, well, maybe they're floating essentially on an ocean of lava.
Yeah.
So the continents are floating around on this lava.
Yeah.
Well, no, not really, but they do spread apart and come together and spread apart and come together. At one point on Earth, we had all of the land, everything that was above water was all below the South Pole, or all below the equator toward the South
wow.
Pole. And right now, we have way more land north of the equator than we have
That's
south
crazy
of the
to
equator.
think
It is.
about.
It's
But
wild.
that's what, like, that scale of
Yeah.
time and movement and
Yes,
I
and that's I think why geologists are
crazy.
kind of like, yeah, okay, they passed another horrible bill,
well, and they go 13 centimeters.
right?
Yeah,
right.
whatever.
Well, 13 centimeters is still a lot, and the
Yeah.
geologists are actually interested in that. But
Yeah.
still, it may be hard to wrap your mind around day-to-day policy changes. I'm sure we're all thinking of each administration that comes and goes as well. Thank God that one's gone.
Yeah.
Stuff like that.
Yeah, but yeah, from a geologist perspective, it means so little. It's just such a blip.
And yet there are plenty of activist geologists who
Yeah.
care and are trying to do things, particularly like conserve the White River, for example. And,
Yeah.
there's a lot of field trips that IU Indy geology students do to try and clean the invasive species out, clean the detritus
Yeah.
out. extra sediment.
A lot of good work happening
yeah.
in Indy.
Yeah, but it's all not geologic scale. So
Yeah. Not on the scale
it's
that
environmental
geologists work
scale.
on.
Yeah.
And we didn't bring it up, but I do think it's so interesting. Just the study of geology is such a global field. All fields are global, but like it's so easy
This one,
to be
yeah.
segmented. You can't in geology.
Oh yeah,
it's
yeah.
impossible.
I mean, the Deccan traps in India affected us just as much as the rise of the North American igneous province. Two big eruptions of volcanic gas and methane clathrates and all the stuff that contributed to the
Yeah.
Paleocene, Eocene thermal maximum
Yeah.
and the other smaller thermal maximums we've
Yeah.
had. Yeah.
Yeah. Oh my gosh. No. Yeah, we can come back. I just thought it was interesting. She it makes sense that this is a global science is a global sport, but
This particular science.
specifically geology,
Yeah.
very global sport.
Yeah, I think physicists think of themselves as not even limited to the universe, never mind
Yeah.
the Earth.
We're a little more limited with geology. We're staying on planet Earth.
Yeah,
but still.
mostly. I do have friends who are exogeologists, though.
Yeah.
So, yeah.
And they are, we love them. They are our friends. Okay, I would love to hear what people thought about the prescriptions in the book. Geology in school. Yeah.
I'll just jump right in and see how many people I can offend how quickly.
Yeah. Offend us.
So I had a liberal arts education. Our
Oh.
instructor here is in a small liberal arts college with
Yeah.
1,400 students.
Liberal arts school.
I think some people would say she has a lot of woo-woo ideas in chapter 6.
Woo-woo. Yeah.
I kind of like when they talk to me, but I think the people who are making the decisions, who are the politicians and the money people, they don't give a damn about any of this. If they can make a dollar today, they're happy for the climate crisis to happen tomorrow. Because when Miami's flooded, they're going to move to North Carolina and Asheville.
Yep.
The groceries become twice as expensive. They don't care. They can afford them.
Yeah.
The people making the decisions don't
People making decisions don't care.
care, and I don't think they'll be moved by chapter 6.
Let me point out that the recommendation, the blurb on the cover of this book, a profound meditation on the richness, depth, and entanglements of geologic time by the Wall Street Journal. So it's one of your arch nemesis, the hedge fund arch capitalists and whatnot. So I don't think they read the
felt
book.
funny.
You know?
Yeah. Well, they clearly didn't make it to the end.
Yes.
They read the science and skipped the end.
But let me push back at you, Fritz, with this. It used to be for, say, the 30 years after I graduated college that the Department of Defense, back when it was called the Department of Defense, actually did a lot of future projections on, migrations due to starvation, pandemics, and things like that. They had an eye on the future because it affected U.S. defense. And during COVID, our friend who is the head of high-speed computing, was the head of high-speed computing for the Department of Energy, was called to Washington to turn the resources of the Department of Energy, high-speed computing, to the problem of modeling COVID. So it's not unheard of for units within our government to treat these as side portfolios. Like it's not their
secondary
it's not their
objectives.
main portfolio, but it is. But they do look at these things. If we had a Department of the Future, we could pull the resources of places like high-speed computing at Department of Energy and future casting in the Department of Defense and all that into one unit together. It's not unheard of for the government to do this. It's just unheard of for it to be so well coordinated.
Yeah. I like that. A hopeful take, but I think most of us, at least I would agree with you, that people making the decisions don't necessarily care.
I worry with the Department of the Future to be easily co-opted by whatever political party is in power. And
Yeah.
that
How a Department of Future could be twisted and co-opted by whoever is
This
in
is a
charge at the
problem with
time.
whatever happens as we switch lead parties every 4 to 8 years. So yeah.
Yeah, definitely a concern if a Department of the Future, but I mean maybe a nice middle ground would be turning future planning, future projecting, putting it at the forefront, more at the forefront instead of a side thing that we sometimes think about every couple years, and like really start thinking about And I mean, she talks about like the 7 generations, like 7 generations planning. Like you're not just planning for this quarter, this year, this decade, even this lifetime. Like you're planning how is what we're doing now impacting people 7 generations from me. Zero corporations planning 7. I don't think corporations are planning 1 generation in the future.
Like historically, as a species, even prehistorically, although I don't want to speak on to my ancestors,
Maybe the cyanobacteria.
we are reactive, not proactive.
We are reactive, not proactive.
Especially every 100 years, it's like we lose our like generational knowledge and overturns. Like we saw that, we see it across the board
Yeah.
consistently. I don't know how we change.
How do we
Department
not?
of the Future. That's how
That's
we
a part.
change.
Which is what it's so funny to think about that, how we repeat ourselves, every 100 years we keep making the same mistakes. But then like in geology, we are such a tiny little blip of time. In like that scale, and thinking about these problems and then remembering where this book started, to me, that's what I loved about this book. Was it the zooming in and zooming out and zooming back in. Got a little bit of whiplash, but very good job of doing that. I just want to give this author a little kudos and talk about the book. I mean, did anyone else have any thoughts about the prescription pad we're given? Or Lori, you can talk to us about what you brought.
Sure, I'd be happy to do the show and tell now.
Show and
I'm
tell.
going to talk about a thing and then pass it around. You'll forgive me if I've forgotten the origins of why I grabbed these from the box, but let me start with pegmatite, which is an igneous rock that is called pegmatite because of its formation. It holds large crystals of different things in a small matrix.
Ooh.
So,
Okay,
a couple of
pegmatite.
examples of that sort of.
Oh my gosh. Yeah, we get to pass. Ooh, oh my gosh, and they're wrapped. You're so organized. Okay, it's fragile.
So you can see the black well-formed
yeah.
crystals in here, which I think they're a smoky quartz,
Smoky quartz.
in a sort of a sandy matrix here.
By the way, I have so much respect for quartz now. For the live stream, do it like the girls on TikTok when they're like showing off. They're like, look at my new lipstick. Rocks on TikTok.
Right. This is a quartz inclusion in a rock from Herkimer, New York. It's called a Herkimer diamond. It's not a diamond. It's a quartz crystal, but these form in Herkimer in very large sizes.
Whoa, that is huge.
Yeah.
Now, I would call that a diamond if you hadn't said that. If I was the owner of that, I would have called it a diamond.
So you can always tell quartz because it has these like pointed, it's like a certain kind of a point with an angle that diamonds just don't do that. They're different crystal formations.
Good to know.
Quartz is going to be mostly silica with some oxygen, and then diamond is carbon.
Okay. It's sparkling, yeah. Ooh.
It's an
Okay.
actual trilobite, but it pops out of its sandstone bed.
Okay.
So we have to be very careful. I want both pieces back.
Okay, the trilobite have to be very
So
careful.
give
It
it a
falls out. Oh my God, that is beautiful and so impressive. That is so cool. So hold on. Did you find all of these like as you've traveled? Have you like purchased what is?
Let's see. I've largely
Because you've taken so
purchased
many. If you,
these.
by the way,
Yeah.
for anyone who knows Andy and Lori, if you have not seen like their photos of their travels, stunning. They go to so many super cool places. You should ask to see photos.
We
Like
just went
it's
to
incredible.
the La Brea tar pits this summer. Very cool. Yeah.
That's what I'm saying.
One of the shocking things about the La Brea tar pits is how, you always think that that herd animals come in much larger numbers than the little lone wolf predators and whatnot. In the La Brea tar pits, there are about 1,000 times as many dire wolf skeletons as there are mastodon skeletons, because a mastodon will get stuck in the tar and all the other mastodons are like, whoa, bro, not doing that. No, you're on your own, bro. And then
Solid
the
reaction.
dire wolves are all like, I'm hungry and it's trapped. I'm going to give it a shot and go after it and sink.
Oh my gosh.
Lots more dire wolves there.
Very interesting.
This is a really tiny little one. It's green schist, and it's very sparkly. And one of the cool things about it is it's formed so deep under such high temperatures and pressures. How does a rock that's that abused end up so pretty? We don't know.
abused. Heat and pressure. Yeah, we will be very careful. All fragile. Rufus. Party foul. Foul on the play. Flag. Oh, it's almost football season, guys. I'm so excited. I'm sorry. NFL season, college football season. Drop it like, and it is no longer hot, but we're dropping it like it's hot. You guys. Eee. No more Red Bulls for you. Don't drop that. Dun-dun-dun. Hey, don't drop that. That's too modern. Oh, we have one last. Ooh.
I want everybody to look at this all over on both sides.
Okay.
This is a chunk of the Canyon Diablo meteorite.
Oh, hold on. This is a chunk of the Canyon Diablo meteorite.
Yeah,
What does
the
that
meteorite that formed Canyon Diablo out west.
Where out
and
west?
it's got its rusted iron coating on the outside, and on the inside it's been cut and polished to show
What?
the crystal pattern of the iron and nickel on the inside. It's called a Widmanstatten pattern. It's a very cool pattern. If you've ever handled a brass doorknob on an old building and it's been polished by human hands acid over the years, you can see the pattern in the brass. That's what you're looking at on the inside of the meteorite here. And the outside is the rusty iron coating that comes roaring into Earth developing.
Lori, this
Why
is
do we
crazy.
care about meteorites in a book about the Earth? Because it's about the Earth, not meteorites, right? But some of the earliest dating of the Earth occurred because the meteorites formed at the same time the solar system did. They're uncontaminated by the whole rock cycle and oxygen and cyanobacteria and humans and everything else. So you can look at the minerals in them and do some dating. It's not carbon-14 dating, but it is a similar activity. You use uranium as it decays to lead to date the meteorite. And so this is one of the contributions that tell us that the solar system is some 4.6 billion years old. Unless Fritz disagrees with me, in which case Fritz is correct.
No, we're cutting it. We're cutting it. Oh, that's so rad. So is the uranium dating the best dating system? Is there
It's
a
just
ranking
the
of best to
longest.
worst?
No.
Okay.
There's just so each radioactive pair, it's mother-daughter pairs they're called.
Mhm.
Each say uranium decays to other things, and then thorium, then down to lead. Those are mother-daughter pairs. Each one has its own time scale. You've heard of half-life before.
Mhm.
Each one has its own half-life. You can use carbon to date things like human remains from 10,000 years ago or plant remains and whatnot. It doesn't get any older than that. The oldest one that I know of is this uranium to lead. There's also thorium to lead. There's also argon 40 to argon 39. And so there's different systems depending on what time scale you're looking at. So geologists are going to use the longer half-life materials,
whatever's
and
available.
your doctor is going to use the shorter half-life ones for the radioactive stuff he makes you drink and then looks at.
Yeah, I hope my doctor's not aging me on a uranium time scale.
He seems to be 2.5 billion years old. Looking pretty good for your age.
Yeah. I hope you guys are having fun. Thank you for bringing those in, by the way. When you said that, I was like,
My pleasure. Is this, I don't know if we're close to the end here,
Yeah.
but let me ask, Did anybody not read this book but enjoyed this talk?
And they want to read it.
Would you like a free
Yay!
copy of this book? Because I ordered 2.
Yeah, okay.
Alrighty.
Yay. I'm glad the book will find a home. Oh, and we have other trilobites. We have more trilobites, you guys. You guys on the live stream, if you're not coming in, what are you doing?
All right.
Lori, you're so full of surprise. You brought so many gifts, so many surprises.
Yeah. We'll have a minute.
We'll have to track down where your rocks went, but I
I
promise
know.
Andy's monitoring the back valiantly. So we will not lose anything. Is there anything?
I need my rocks back.
Yeah, we do need the rocks back. That is, yeah. Andy has collected all the rocks. Beautiful. I wanted to make sure 5. Yeah, that's correct.
5. So you have the pegmatite, the
Diamond.
Herkimer diamond, the
Meteor.
sandstone with its little trilobite. You have the schist, the green schist, and you have the meteorite.
Yes. Okay, we
All
have
right.
them all. And if you didn't,
Ach, mir Gott.
Oh.
Would you like to come?
yeah, you guys can come over and look. And we can wrap this up and we can talk for the live stream. You all, it's hard to show and tell. But thank you guys. Yeah, they have the rocks over at that table if you just want to go over. I promise they don't bite. They don't bite. Well, too much. We're friendly. But I want to say thank you guys so much, obviously, for coming and talking. Thank you, Lori, for bringing so many gifts and so many fun things. If you haven't started, if you haven't followed us like on social media, you're not part of our email list. Next month, September, we're going to be reading The City We Became by N.K. Jemisin. And if you are local to Indianapolis, which I think most of you are, but for those of you on the live stream, Butler University is actually having N.K. Jemisin come give a talk on September 24th at 7:30 p.m. on campus at the Art Center. I don't know. I'm not at Butler. It's a ticketed event, but it's a free ticket. But I think you have to sign up online ahead of time. So if you start reading this book, again, The City We Became, it's her newest novel. By the way, very good. I've already started it. And if you have Spotify Premium, it is free and included. And there's a lot of really cool sound effects and music, and the audiobook narrator is very good, like changes voices and like I feel like I'm watching a movie even though there's nothing visual, if that makes sense. Highly recommend the audiobook wouldn't recommend it for Timefulness, would recommend the audiobook for The City We Became. And then again, if you realize if you like N.K. Jemisin, or if you start reading this book and you're like, I think she's really cool, she'll be at Butler University September 24th. And you can go see her talk about not just this book, but all of her works. Obviously, she's a award-winning author. I'm so excited to read this book next month. And thank you guys. And chat soon. Bye. Thank you. Lori, thank you for coming.
Sure.
And thank you for bringing all these rocks and all the
Sure.
books. And it's
Is
just
the
amazing.
radio part done now? too?
Yes.
Cool. All right. Did we go long enough?
Yes. Okay. Perfect timing. I would try
Okay.
to end a couple minutes before 8.
Okay, good,
So
good,
people,
good. Because
you
I
know,
thought
people
you were
stand-
supposed to drag this out a little bit longer.
No. Perfect. Beautiful.
Good. Yeah,
So we
well,
don't wanna
I'd be
be like,
happy
wah,
to
wah,
do it
wah, wah.
again, not anytime soon, because as you mentioned,